All right, let's look at another problem here. So the training heart rates of all 20-year-old athletes are normally distributed with a mean of 135 beats per minute and a standard deviation of 18 beats per minute. So some key things here. And one of the biggest one is that all are normally distributed. So our population is normally distributed. And then we have our mean, and then standard deviation, and then they give us our random sample size. So there's our normally distributed data of our population. So we want to find the mean. Well, our mean is equal to the mean of our standard deviations, which is 135 in this case. Okay, and then we want to find the standard deviation of the sampling distribution. So identify our standard deviation, which is 18. Our n, our sample size, is 4. So the standard deviation of the sample size is 18 divided by the square root of your sample size. So 18 divided by 2, which is 9. And then sketching a graph of our sampling distribution will also be normally distributed. All right, we have a mean at 135, and then our standard deviation of the sampling distribution is 9, so 144, 153, 162, and then going down 126, 117, and 108 for our sketch of a graph of the sampling distribution. All right, so let's connect probability, which we've been doing, to our new topic of central limit theorem. So we learned how to find the probability that a random variable x will lie in a given interval. In a similar way, we can find the probability that a sample mean will lie in a given interval. And so we have our z-score. So that should look familiar, right? We have our value minus our mean, which is what we've been comfortable with. Notice that the mean is that sampling mean, which is just our mean. Our value is, and then our value is just our sample mean of the individual ones we're looking for. The one change is now, instead of standard deviation, it's our standard error, right, which is the standard deviation of our sampling means. Right, so using that same formula we've been doing that we did over on number 5 previously. All right, so let's look at this context here. So the figure shows the mean distance traveled by drivers each day. You randomly select 50. All right, so that's key. So 50, so we're greater than 30. So we know our sample means will be normally distributed. What is the probability that the mean distance traveled each day is between 19.4 and 22.5, assuming a standard deviation of 6.5. Sample size is greater than 30, as we said, so we can use the central limit theorem to conclude that the distribution of sample means is approximately normal. So let's find the mean and standard deviation of the sample means here. So the mean of our sample means is going to be equal to our mean. Looking at drivers 16 to 19, so we got 20.7. So there's our mean of our sample means. And then the standard deviation, we had a 6.5. And n was 50. So then we have the sample standard deviation is 6.5 over the square root of 50, which then gives us 0.919. And now we can find our z-scores for each of these individually. So z equals our value, so 19.4, minus our mean, which is 20.7, over our standard deviation of the sample means, or our standard error, so 0.919. And our second z, we call it z2. We have 22.5 minus 20.7 over 0.919. And so for z1, we get negative 1.41, and for z2, we get 1.96. All right, so now we want to find the probability that the mean distance traveled each day is between 19.4 and 22.5. All right, so we can take our z-scores. Now I'm going to show you some technology using Stapplet that we can do this with. And so taking both of those, if we go to Stapplet, all right, and then we go under probability, we have our normal distribution. Click on that, we can type in our information. So our mean was at 20.7, and our standard deviation was 0.919. We want the area under the curve, so we're going to plot that distribution. So you can see our sketch, and then we want to calculate the area between two values. So you get this little drop down to the left, to the right, or outside of. So we're looking for between two values. Our left bound was 19.4, and our right bound is 22.5. And we can calculate that area, and you can see the nice shading, and it calculates our area, also showing our z-scores in addition to that as well. Okay, so then the area, the 89.63%, is our probability, giving us the answer. So let's take that back. So we got 89.63% as our probability. Let's label this. And again, we're looking between those two, so 19.4 and 22.5. So that was our shaded area, and that is representative of 89.63%, or probability that the mean distance traveled each day is between those. All right, let's look at a second problem application. So the mean room and board expense per year at a four-year college is $10,453. You randomly select 9 four-year colleges. What is the probability that the mean room board is less than 10,750? And we're going to assume they are normally distributed, so that's key. All right, because our n is not greater than 30, and so we can't apply the central limit theorem. But since it's normally distributed, we are good. And then we have a standard deviation. So let's key on those. So our mean is there. Our randomly selected, our n is 9, and we have a standard deviation of 6. Okay, so our mean of our samples is equal to the mean, which is 10,453. Our standard deviation is 1650. Our n is 9. So the standard deviation of our sample means is 1650 divided by the square root of, which gives us value 550. So the next we want to find the z-score that corresponds. So z equals our value minus our mean divided by our standard error, or the standard deviations of our sample mean, and that gives us a value of 0.54. So then they want to find the probability that the mean room and board is expensed is less than 10,750. So let's fill out our sketch here. So going up, remember we're adding 550, and then we're looking for, we want 10,750 and less than that amount. That's somewhere in here. We got less than, so we're looking for that whole area there. And again, we can take this information over to Stapplet now. All right, so we had a mean of 10,453. Our standard deviation of the sample means is 550. So go ahead and plot that distribution. And we don't want between two values this time. We want to the left of a value, and our value was 10,750. We'll calculate that area. Shows our z-score of 0.54 and an area of 70.54. 70.54% is the probability that a given college mean room and board expense is less than our 10,700. All right, go and try these two problems on your own.